Hi, Spring fans. Welcome to another installment of Spring Tips. This time I wanted to talk to you about something brand new and amazing and yet old and boring. I want to talk to you about the brave new world of boring. You see, today we're going to talk about YugabyteDB. YugabyteDB is, from the developer's perspective, it's just Postgres, but it's not. It's definitely not. It's a distributed database that offers scalability and performance on par with the sort of NoSQL giants, the Apache HBases, the Apache Cassandras, etc. It's a database. We all love databases, right? They give us our data. They hold our data. After all, our data will outlive our applications, and we want our data to be well taken care of. It's for this same reason that we fear data loss. Intrinsically, I get nervous just thinking about it. My throat dries up. It's not good. I'm verklempt. Data loss is the database administrator equivalent of a jump scare in a horror movie. It's like finding out that your security software's cloud component is running PHP. Ugh. Databases are key to everyone's imagination of what a useful computer can do. They occupy a big part of this culture of technology, right? And sometimes this leads to, humor, sometimes fun, sometimes terror bad. Humor like the notorious MongoDB YouTube meme, it's web scale. I'm sure you all know that one. And this stinker of a headline from TechCrunch, Yugabyte stores up 188 million more for its open source distributed SQL database model, and so on, right? It's part of the zeitgeist of everyday parlance, right? Nobody wants to lose data, and a big part of the discussion from the last 20 years, the era of big data and all that, has been around how to bend the rules of physics to break the CAP theorem. How do we get consistency, availability, and partitionability, right? You know the CAP theorem. You can have consistency, availability, or partitionability, but you can only pick two of those, right, of the three. And so it's been a long journey. We've been trying to make it so that our databases keep our data and make the data available whenever we need it, however we need it, at whatever scale we need it, right? And obviously, there are trade-offs. Nothing is perfect, but we've gotten pretty close, right? We've gotten pretty close with YugabyteDB. Obviously, like I said, it's been a long journey. In the early 2000s, Google created MapReduce, which they created to describe, processing on their distributed cluster. It's a very simplistic programming model, but it has its merits. Doug Cutting, then at Yahoo, created something that would become Apache Hadoop. And obviously, I have a little. It's a bit of an annoyance to me that there are companies with exclamation marks in their name. So, maybe it's because of that. Maybe that's why Hadoop isn't so popular these days. I don't know. Probably not. Hadoop was amazing, but it was criticized for being too low level. It's a programming model that basically relies on a functional programming paradigm where you map and reduce data. It was only natural that solutions would arise to sort of plug that considerable usability gap, right? Solutions to help with querying and processing and so on. These solutions took many shapes and sizes, but they were all trying to plug the considerable usability gap in modeling, querying, and processing on top of MapReduce. There were several attempts at this, including, among others, Hive, Pig, and of course, Apache HBase, which was a columnar database created by, among others, Yugabyte CTO and founder Karthik Ranganathan. Karthik is amazing. He also would later on go on to co-found Apache Cassandra, so clearly he knows his stuff. HBase and Cassandra are dope. Obviously, HBase optimized for transactional sort of online data, whereas Cassandra optimized for availability. It was completely distributed, right? There's no single node of failure. Both have their virtues. And of course, Spring tried to bring as much of this ecosystem as close to the application as possible with projects like Spring for Apache Hadoop. Karthik worked on those two early NoSQL databases, and at the time, NoSQL more often than not meant not SQL, as opposed to the more contemporary definition of not only SQL. Yes, these databases were exciting and bold and brave and different, and they had caveats. They weren't like what you had before. They weren't familiar. They were strange, brave new worlds, right, in which your data could live if you were willing to learn the the lingo and walk the walk. And there were a ton of great models that came out of this, right? A lot of great different databases that have served us well, including, but not limited to, MongoDB, Apache Cassandra, Redis, CouchDB, and Membase, the last two of which became eventually Couchbase, and many others besides. One trend that you can't ignore, however, is that these databases, these days, a lot of them are working to make writing and working with SQL-like DDL and queries easier. That is to say, they're trying to bridge the divide between the existing Brave, distinct programming model and the very large majority of people that want to use SQL. So Couchbase these days, it has Nickel, Cassandra has CQL, Google Cloud Spanner has its own SQL subset as well. So there's always some caveat. It's brave and exciting, but there's a caveat. It's not familiar. Then along came a new generation of options. The new SQL database vendors, inspired in part by the likes of Google's Spanner database. This is the stuff that I've been waiting for, right? This generation is all about giving us a SQL-like experience that, for all intents and purposes, is standard SQL. This generation of databases is all about getting us a SQL-like experience that, for all intents and purposes, is standard SQL. There are a few databases, if any, that offer more and with the right value proposition than Postgres. PostgreSQL is an amazing database. I'm a big believer. I was completely convinced that at some point, Postgres would dominate and take over the market. And, anecdotally, kind of feel like that's happened. I don't really hear as much about MySQL or MariaDB anymore. I know it's certainly still out there, but Postgres has gained a lot of traction. And it's because it works. It's fast, it's scalable, it's got a lot of features, and it's open source, right? So I've always loved Postgres. But, at the end of the day, Postgres is not Apache Cassandra. Cassandra is what you use if you want to scale. HBase is what you use if you want to scale. But if you want the richest domain database, one of the richest databases out there, full stop, you want Postgres. And I've always just thought it's a bit of a pity that these things don't connect. You've got the brave and exciting and bold Apache Cassandra world, and you've got the boring Postgres world. And if I had to pick one database to reach for to include in my application, if I could only pick one, I'd start with Postgres, right? Postgres has always just been amazing. It's boring, but it works, right? So this is where Yugabyte comes in. Yugabyte is a different database because it uses the Postgres front end. It acts and speaks Postgres. It has the same protocol, the same clients, etc. But behind the scenes, it's a distributed database built on a completely different engine. This is a unique and rare opportunity, right? It's an amazing piece of technology, and that's what we want to use, right? We want to use it because we can use it in the way we would use any Postgres database or any SQL database, really, to build applications. And then we're going to marry that with other technologies like Spring, which has been around for a good time now, a good long time, and Spring Native, which supports building native images using GraalVM. These things are perhaps a lot more familiar, a lot more well-entrenched, and they're boring. And I love boring, right? I love it because it's what allows me to get to sleep at night. Nobody's ever come to me and said, "Oh, I'm so excited that my brave and exciting new database is failing in mysterious ways at 2 a.m. That's not a thing that people say because it's not interesting. Nobody wants to be awake at 2 a.m. debugging the unknown. That is hopefully behind us, right? And there's a lot of reasons why that's true. One is because of the prevalence of cloud-hosted SaaS offerings where somebody else wears the proverbial pager, first of all. And then two is because we're building on well-understood, operationalized technology stacks like Postgres. We're going to get the best of all worlds. We're going to build something that scales, but have it backed by something that is very, very familiar, right? We're going to use reactive programming. We're going to use native programming. And to get started, we're going to need a database. So first things first, let's hop on over to our browser, and we're going to go ahead and set up an account, a cluster, and then we'll dive into writing some code. Let's go. All right. So we know what we want to do. We want to build an application that uses the Yugabyte database. There are many ways to get started. Obviously, there are Docker images you can use, or you can just download the binaries proper. But for my money, it's time as well, right? For my time, I much prefer to spend the money. And for my money, I much prefer to use Yugabyte Cloud. So cloud.yugabyte.com, easy to remember URL, just add cloud to yugabyte.com. log in. It's easy to create an account and then create a cluster. Now, you've got a couple of options here. You can create a free cluster, which is the default, and that's the big button they show you, or you can pay for a more sturdier, beefier, whatever cloud. I'm going to do that just so you can see what's going to happen, and then I'm going to very promptly delete it as soon as we're done with this, because I don't have a production app in production that would need this. But the point is, it's nice to know that if I did, this is where I would go, right? This is the solution. This is free. You can definitely use this to poke around and kind of explore the space and see what you can do. It has everything you need to build reasonable working applications, and you might even be able to achieve some scale, right? It's not insufficient, certainly. It's just not the next level sort of thing you expect. There is Yugabyte Cloud. Like I said, this is 50 cents an hour, right? So $12 a day, and that you can see that kind of that gets expensive, right? So hit next. Where do you want to run this thing? I'm going to call this cluster called Spring Tips. We can run it on AWS or GCP. I'll choose GCP. It adds up pretty quickly. This is American dollars, US dollars, as opposed to Singaporean or Canadian or whatever. And it's more than $1,000, right? That's a lot of coffee. So again, make sure you don't choose this by accident. But if you do need it, look at this. This is a really good setup here. You get 3 nodes, 2 vCPUs, and 100 gigs of disk space, right? So this is the distributed, fault-tolerant configuration you want for a real application. $12,000 a year is chump change for an application that pays for itself, right? So this kind of thing is, I just love this. And I don't have to manage this. I don't even have to set up, I don't even have to unlock a port in my local machine to use this either. I do have to, as we'll see, I'll have to configure a port on that thing. It's going to give us some credentials. Make sure we download those. Okay, and then we're going to scroll down, create cluster. And this will take a few minutes. Actually, it says this can take as long as 15 to 20 minutes. So we'll let it do its thing, and I'll see you on the other side of the jump. Okay, the cluster is ready. We are able to now connect to it, but before we do that, we have to tell it, if we want to test on our local machines anyway, we need to tell it where we're coming from. So we go here, we click on Add IP to the allow list. I'm going to add home, hit save, and there we go. Now we have exempted ourselves, and we can connect to it, and we have a few different options. Obviously, you can get the credentials you need to connect your application here, right? All this stuff, you're going to want to keep that for later. So we go to my little file here that we downloaded, the credentials. We're gonna, let's see, downloads, Spring, where did it go? Desktop. There, this file. Let's save it here. Creds.txt. Okay. And we're going to want to copy all this information, note it for later, keep that there as well, okay? Now, obviously, I intend to dismantle this cluster as soon as we're done recording this, so, this won't work for you. You need to get your own, okay? All right, so there's our credentials. Keep that for later. Good stuff, so we got that. But then for my actual interactions with the database, I use the Cloud Shell. It's convenient, it's fast, it works, so hit configure. I'm going to use this password here. Okay, and it wants the password. I'm going to paste the one that I just copied and pasted from the text file. And there we are. And you can see it's actually just basically a Postgres terminal, right? I can actually use the same meta commands, like \d to list all different tables and all that kind of stuff. So you can see I've got nothing here, right? Did not find any relations. Now we're going to build an application to talk to it. And from here, it couldn't get simpler, right? Couldn't be any simpler. We're going to build an application, as we always do, by going to my second favorite place on the internet, start.spring.io. We're going to call this Yugabyte for the win. We're going to use Java 17. It's the right thing to do in 2022. We're going to bring in the reactive web support. We're going to bring in the Postgres driver. We're going to bring in R2BC, which is a reactive relational database connectivity abstraction. And that's it, I think. Oh, wait, no. And one more thing. We want Spring Native to build native applications. Okay? So I've got all this. Quick review. The reactive web support is going to give us support for building reactive web applications in the same way that R2DBC gives us support for building reactive SQL-based applications. When I say reactive programming, I'm talking about a style of programming that allows us to better repurpose threads. Because you think about all the things that we have to do in a given computer program, a lot of things we have to do, they have to be done on the CPU. Things like the Fibonacci series and cryptography and any kind of security and math and this kind of stuff tends to be on the CPU or the floating point graphics processor or whatever. But the point is, there are some things that you can run on the CPU that don't actually take advantage of the CPU. So one of those things might be blocking, busy waiting, when you're sitting there on a thread just doing nothing, while loop forever, right? That is keeping a thread which is on a CPU hostage, right? You're not able to use that thread. Nothing else in the system can use it. And so it creates a very inefficient system where you're not sharing the resources of the system, and threads are limited. They're finite, or at least they are for now until Project Loom comes. And then we have two other concerns, right? We have threads. We want to make good use of them. But the way we do that is we use this unified abstraction, the Reactive Streams specification. It gives us this type called a publisher. A publisher allows us to describe a stream of data. It doesn't matter the size, the cadence, the velocity, the frequency of that data. It allows us to easily describe it using one type. So we're no longer having to spend all this time when you build microservices and all that, adapting one payload, one type of stream of data to another. The life cycle doesn't have to. You don't have to glue these things together because they are the same thing. They're one of a piece, right? They're the same type, and they compose well as a result. So if you want to take data from your database, even a massively distributed, uber scalable database like YugabyteDB, you can, right? If you want to take that data and then send it over WebSockets or send it over Kafka or whatever, you can do that, right? Because they are the same type. They're both publishers. Ultimately, right? Life becomes very easy when you use reactive streams. And because we have this single abstraction, this single unified type, then we have a natural benefit, which is what we have a single place in which to interpose reliability operators, things like retry and graceful degradation and back pressure. Back pressure in the reactive world refers to the idea of handling the situation where one side of the communication exchange is going faster or slower than the other. How do you keep up? How do you contend? How do you push back against the overwhelming torrent of data? All of this is something you will need to take care of when you build your applications, because we want our applications to be worthy of the incredible scale implied by something like YugabyteDB. And finally, with those three benefits, right, you get resource efficiency, you get ease of composition, and you get reliability. With those three benefits, you can write applications that are as efficient as can be on the JRE, on the JVM, and they do the most efficient thing possible. But at some point, you're still stuck with Java, right? Java is awesome. It's what big boy and big girl websites use when they want to scale and meet the demand. That said, it's still an application that runs on an interpreter, basically. There's this thing called a just-in-time compiler. It adaptively compiles your interpreted bytecode into architecture and operating system specific binary code, right? So you might have a Mac, you might be running on a Mac as I am, and you'll get Mac specific, native code interleaved into your interpreted Java code. And it's only done for parts of your application that are frequently run. Well, this is fine, except, why not proactively just compile the whole thing into native code? Why do we have to have some parts in Java and some parts not? Well, the reason is because it's hard to approximate all of what Java offers and purports to offer in a native world without some extra information that the compiler can't glean necessarily from just a sort of straight look at your application. And that's because Java is a very dynamic language. For all of its stodginess, it actually has a lot more in common with the likes of Lua and Perl and Python and JavaScript and what all, right? It's very dynamic. You can write a string, you can load the string into a compiler, create a class file on the disk, load that class into the class loader, reflectively create an instance of that class using reflection, invoke methods on that class using reflection. If you want, you can make an instance of a class that implements that interface that you just created and create a proxy out of it, and then you can have that proxy be serializable, and you can write the bytes to disk and then load it on some other JVM. And you can do all of this after the JVM has started and the application has started running, right? After all the compiling has long since been completed, you can actually do everything I just described, which is amazing. You can do eval, basically, right? That dynamic behavior is one of the credits to Java's, amazing capabilities, right? It's one of those things that Java does well, and it makes it a very dynamic language and ecosystem and platform. And the Graalvm, the native compiler, it can't see that. It can't see a lot of that dynamic behavior. So you have to give it extra information in the form of hints. And so we have a project called Spring Native that feeds that information to the Graalvm native image compiler. The result is that you get an architecture-specific binary for your application that uses reactive programming and that talks to a world-class globe scaling database in the backend. I mean, you're now using the best of the best tools out there, right? You're doing this. You're building an application that is using familiar, tried and true, well understood tools, but you're getting the best world-class kind of performance and scalability and efficiency as a result. These Graalvm native images can take 50 megs of RAM as opposed to your typical sort of 500 megs or more on the JRE, right? That's amazing. That gives you a really, really interesting opportunity. You can build applications that scale, right? That are worthy of the incredible scale offered by YugabyteDB. So let's go ahead and do that. Let's go ahead and hit generate. We're going to open this up in our IDE. So we're going to open this up in our IDE. So we'll go to here and we're going to say UAO Yugabyte for the win.zip. It'll open up in my IDE, so we'll wait for that to finish. All right, it's finished indexing. It's loaded into the IDE. Let's go ahead and get a feel for the lay of the land. We've got our public static void main entry point. We've got a property file in which we can configure, we can specify the connection information. Now, I'm doing a demo here, friends. Don't do as I do, do as I say. I'm going to use this property file to write down the username and the password and the host and the port of my database. Naturally, that's a terabad idea, and it makes Spring Security Lead Rob Winch sad. Don't do it. Be the change you want to see in the world. Do the right thing. Externalize your configuration. Look at the 12-factor manifesto. That's only like 12 years old. They got it right. Let's do that. No, and Spring Boot has great support for that. But so that we can kind of see what's what, I'm going to show you everything here. What you do is you have a property like this, okay, spring.rtbc.url. We need to specify that connectivity information. So I'm going to copy all that stuff that I got back from the website here. And we're going to say RTBC PostgreSQL. And I'm going to specify the host, which is this bit right here. And then we want the Yugabyte schema. And then we need to specify a username. And the username is admin. And the password is this right here. Now, this is most of what we need, but we also need to specify some information about the SSL. So let me go find that and we'll put that in there right now. Okay, the last thing we need to add is the question mark there. SSL equals true and SSL mode equals required. All right, good stuff. Now we're going to be using a remote database. That is to say, it's not one that's embedded in the Java process itself. And so we also want to initialize that data source because we're doing a demo. So I'm going to use Spring SQL init mode equals always. That way we can initialize the schema, the DDL. Now I've hard coded all this in my property file. Obviously that's a terrible idea. You might hard code like the credentials for a local Docker image that everybody on the team uses for development, but for production you want to override these values. And the easiest way to do that in Spring Boot is to use 12-factor style configuration by externalizing everything into environment variables. So Spring supports this convention where properties that took a period in between the tokens can be separated through with underscore. So this is an underscore here, and that's an underscore, and then the value. So that's an environment variable that you would put in the shell script that runs your application, right? Or you could configure a config map and then load that as an environment, or you could use a config tree. Spring Boot supports that, but either way, you don't want your configuration living in the application proper. I'm doing it, but it's just a demo. So in that spirit, let's just connect. Let's see if everything works. Let's just start the application and see what we get. All right, good. Looks like we're connected. It hasn't done anything. There's nothing here, but there's no exception, no connection exceptions, etc. So we're already off to a good start. Now, what I want to do is I want to write some data to a database. I'm going to create a type here called customer to manage our entity, and we're going to specify that this has a primary key, and we're going to create a repository to manage the tedious, soul annihilatingly boring read, write, update, and delete data management lifecycle. And then we're going to work with that data. We're going to actually write that data to the database here. So I'll create a bean application runner, right? Return args, and here we're going to just inject the repository. We'll say repository that, and we don't want to use a repository. We actually want to use a service, don't we? So we'll say customer service, and we're going to say private final customer repository. All right, and we're going to have a method that we expect will do some things in aggregate. So we want to create a transaction, and for now, let's just keep it simple. What do we say? We just take these names that we've just been given and turn each one into a new customer, like so, and then map each one to the database, like so. Okay. Now, that's going to write the records for us. This is going to be a regular Spring Bean. We're going to use the stereotype service annotation there, and we can inject that, not the repository, into our bean definition. And so we'll say service.reset, and we're just going to provide some names, A, B, C, D, and then we're going to subscribe. So we'll just print out the results as they arrive. Yeah, so here we are. Good stuff. I don't know how to, yeah, whatever. There's no right way to do that. Okay, so let's just run it and see what that gives us. It's probably going to fail because we haven't initialized the schema, right? Is that true? Looks like it has not failed, which is curious to me. Is something as yet unspecified? Let's see, we added this, so that should be there. We're already in the Cloud Shell. Let's see if that got created. No. Okay, it could not have worked because there's no schema. So therefore, something's amiss. Do we have the right database driver on the class path? It looks like we have both of them. We don't need the JDBC one in this case, so we'll remove that. Let's create a schema file just to make sure that at least gets loaded. Okay. Schema.sql, create table, customer, ID, serial, primary key, name, varchar, 255, not null. Okay. So we go back to our application, restart. Oh, there we go. Look at that. As we were running it, there we go. Transaction could not connect to unresolved. Okay, what is that? That's promising. So this is the host and port, Yugabyte. What's the schema name, I wonder? Yeah, it's called Yugabyte. Looks right. Connect. Yeah, okay, we'll just copy and paste that whole thing. Okay. That looks right to me, although it looked right the first time too, if I'm honest, so I'm not sure what the issue is. Has my IP address changed perhaps? Add IP list, create new, detect. Oh, it has. Ha ha ha. Okay, so we're gonna add this home 2. Okay. So that'll take a minute. We'll let it do its thing. That explains it. Again, this is a little bit of an inconvenience, but what you want is a database that is secure and locked down by default, right? This is scalable and secure by default. It's boring. I love boring. Boring allows me to sleep well at night. Boring allows me to know that even if I just do my little thing and just ignore the rest, it'll probably still be okay, right? So let's let that finish. I'm not sure if it's ready to go. Oh, look, it finally connected. Okay, so that actually connected sort of, I don't know, it must have connected sometime after I clicked that add button. So let's retry. Okay, now it's unhappy again. So the customer already exists. So what we want to do is we want to change our schema, say if not exists, okay? And, you know, I also want to, we're going to have another issue. Let's say we run this again. Okay, if we go to the shell, select all from customer, you've got the same data, right? So delete from customer, okay. There's nothing there now, but we're going to have the same issue as we rerun this application. So what I want to do is I want to reset everything, hence the name. So first, this is the write operation, but what I want to do is I want to delete all first. I'll say this dot repository dot delete all, and then write. So I'm going to say delete, then many write. Yeah, okay, there we go. There's our updated operation. So I'm doing two different things, and I want these both to succeed or both to fail. They're atomic, they're transactional, they're a unit, right? So I'm gonna either both of them can work or they roll back and they don't work. Okay, so there we go, A, B, C, D, and that's indeed what we've got there. So if we go to our schema here, not here, here, select all from customers, there we go, A, B, C, D in our SQL database. Good stuff. Okay, so we've got our records. Now let's actually create a little scenario where we have to roll back. Okay, so lowercase e, and then I'll do some validation, right? I'll say on, do on next, and I'm going to just have an assertion. I'll say assert is true, c.name.char at is a capital letter. We'll say character dot is uppercase, and then we'll say c.name.char. There you go. So we want this to be the first letter must be uppercase. All right. Pretty trivial example, but you can kind of get at what's happening here. So basically, it's going to write everything in this method, and then after it's all been written, but not committed, we're going to then do some validation. Should I have done this before we do the reset? Yes, absolutely. But this will give us a chance to demonstrate that when you use transactions, it rolls back everything. Okay, so the effect of this should be that we still have the same records in the database. So if we go here, we can see that these IDs are 202, 204, 203, 201. Let's go ahead and rerun the application. Okay, it's thrown an exception. So we got the it wrote out what it thought it was going to write, but let's see if it actually reflects that in the results. There you go. Select all from customer. Those records that it thought it was going to write, but then some validation error occurred, never got written. So we still have the same 4, and that delete operation that we thought we did, where we deleted everything, never happened, right? Because it got rolled back. So let's try this again. This time I'll fix my lowercase letter, and I'll try again. So this time I'm expecting to see 5 records with different IDs in the table. All right. So there we are. All the originals are gone, and the new data is there. Have you seen this before? Sure you have, right? I mean, this is the support for reactive, this is reactive transaction demarcation, which has been in Spring for years. It's based on transaction demarcation in general, which has been in Spring for, I'm not even kidding, like, 18 plus years. And by the way, Spring, on the 24th of March, which is the day I'm recording this, celebrates its the 18th birthday since Spring Framework 1.0 came out, right? So to think, I mean, is that right? 2004? Yeah, that's right. 2004. It's a very old, amazing piece of software, and it's had declarative transaction demarcation for a long time. It's just that seeing it with something of the sort that YugabyteDB is, that's kind of interesting because you're not, at least in my mind, maybe you're all, no doubt you're all considerably wiser than I, but in my mind, you don't get to have scale and consistency, you know? That is the cap theorem after all, you have to pick two. Whereas here, it kind of feels like we're kind of, I don't know, goosing it a little bit, right? I mean, it feels like we're cheating. We're getting most of all three, right? Which is important. It's nice. Okay, so that's a boring application. You know, obviously I could build a little REST endpoint. I could do all sorts of things here. But I'm more interested at this point, now that we've kind of seen that our data model is coherent and that our database is working as we expect, I'm much more interested at this point in getting into production. And these days, as often as not, production is some sort of Kubernetes environment. So, of course, I can use the build pack support in Spring Boot. But before I even do that, you know, I can leave that for another topic, another time. What I really want to do is I want to turn this into a Graalvm native image. Like I said, it's a Graalvm native images are awesome. They offer the opportunity to build applications that are very, very small. And so I'm going to build that image here by, first of all, stopping the existing run. And then I'll say maven -p to activate the maven profile for native, skip tests, clean package. And we'll just let that run. It's going to run in the background. This takes about a minute, maybe a minute and a half. I don't know, you know. But we'll let it do its thing, and then we'll come back after the jump. Okay, so it has finished about a minute later. Now we go to the target directory. And you can see we've got our regular jar, right? Java -jar, yugabyte.jar, right? That's the actual application that with which we're familiar, but we've also got this native binary. Look at that, huh? So I hit allow because it made a network connection. Let's Control-C that again. Okay. There we go. So it's connecting. Remember, it's making a network connection to Yugabyte, which is running elsewhere. But if you were to run this exact same application and point it to a local instance with no network handshake and all that stuff, you'd find this application, you know, it could start up in 40 milliseconds, right? 40 thousandths of a second. But that's not all. My favorite part about this is it's also much more memory efficient. So pgrep, I was about to say pgres, I don't know what that is, but I'm thinking of Postgres and something like that. Okay, so pgrep yugabyte. Okay, there's my PID, my process identifier. So I'll use my little shell script here to measure memory footprint. RSS by pid.sh. There we are. All right, so it's 95 megs to run this application, which has an embedded web server. It has the whole JRE, or at least everything it needs to run, the whole JRE. It has, you know, the connection, the driver, all that stuff. 95 megs, right? That's awesome. That's awesome. So now I can take this, I can easily put it into a Docker container using, you know, just the most trivial of Docker files. You don't need to download a JRE after all. It's just a native binary. You can actually, and there's actually a Graalvm GitHub action that you can use so that you can just do cross build. You can cross compile for Mac, Windows, Linux, whatever. Obviously, these days, more often than not, production is a container on a Linux, you know, host, right? So you really only need Linux for your production build. But the point is, you can test that everything's working as you expect on your Mac by using this support that I just showed you. All right, my friends. So with that, we have looked at the, you know, thrilling, brave new world of boring. Right? We've looked at things that should seem and are very, very familiar and old, right? Nothing here you haven't seen before if you've been paying attention, certainly. And yet somehow it's not at all like what you've seen before. It's a completely different thing. And I love it. Here's to the brave new world of boring. Thank you so much for your time. Hope you got something out of it. And as always, see you next time.